I'm recording this lesson. So let's take a look. Chapter 8 in your book is where we kind of dive into something completely new. And what chapter 8 is right triangles and trigonometry. Right triangles and trigonometry. And so we see that this chapter has 6 lessons. We'll have a mid-chapter quiz after lesson 3, and we'll have a test after all 6 lessons are done. Okay? So you guys don't need your phones right now, so I'll let you know if you need calculators, and you can take them out and then put them back. So let's take the phones off the desk, so I can just see them being too much of a temptation. So we'll have a mid-chapter quiz, and then a test all the way at the very end after lesson 6, and we'll obviously have a review day after lesson 6 to make sure you guys understand it. But we start to see here, this first lesson is in similarity and right triangles. Then we get into trigonometric ratios, and then we kind of start using these trigonometric ratios and learning different things about triangles, basically. So it kind of develops all the way into the end of it, which is vectors. Okay, so let's go ahead and get started. The beginning is similarity in right triangles. Okay, and what does this say? Go ahead and read Theorem 8.1 to yourselves. Read Theorem 8.1 to yourselves. Okay, so this theorem says the altitude to the hypotenuse of a right triangle forms 2 triangles that are similar to each other and to the original triangle. So check it out. We have, how many triangles do we have in this picture? 3. Good. We have the biggest triangle here in blue. Then we have the middle triangle here in red. And then we have the smallest triangle here in green. You guys see that? Does that make sense? So there are 3 triangles in this picture. Now, how do I make a similarity statement about these triangles? Well, check it out. What do I notice? I notice that all of them have a right angle, right? Look, the biggest triangle, here's the right angle. The middle triangle has this right angle here, and the smallest triangle has a right angle there. Okay? The altitude is this. CD is the altitude. You see that? The altitude is CD. And the altitude connects the right angle to the hypotenuse, just like that. Okay? So, how do I make a similarity statement? Well, when I'm making a similarity statement, this little squiggle here means it's similarity. Okay? So it's like a sideways S almost. It means this triangle is similar to this triangle, which is similar to that triangle. So all 3 of them are similar to each other. Now, the thing is, you might just say, okay, well, this triangle ABC is similar to ADC, which is similar to BDC, right? And just put the 3 letters that are on the triangle and think, oh, okay, they're all similar, that's how I describe it. But you can't just do it that way, it's not that simple. I have to make sure, and now listen carefully, I have to make sure that the letters are in the right order. The question is, how do I make sure that the letters are in the right order? Okay, so the question is, how do I put the letters in the right order? How do I do that? Well, I start with the right angle. I start with the right angle, then I do the smallest angle, and then the last angle. What do you mean by that? I'll explain. I could do it in any order I want. Alright? Any order I want is fine as long as I'm consistent. But I've determined, basically in my own mind, that the best way to do this is the way that I'm going to show you. Now, I have to make sure that I'm talking about the same angles in the same order. So first I'm going to determine which is the letter that marks the right angle in all the triangles. So in this biggest triangle, which letter marks the right angle? C. Okay. So for the biggest triangle, it's C. And what's the right angle in the middle triangle here? That's the middle triangle. What's the right angle? D. So I'll put that one first. Okay? And then what's the right angle for the smallest triangle here?
B.
No, B is not the right angle.
D.
D. D is the right angle for that one as well. So I put a D. Okay? And then, now remember, this is the biggest, middle, and smallest triangle, right? So I start with the right angle, and then I look at the smallest angle. Which letter shows the smallest angle for this right triangle?
C. C. No.
For this, the biggest triangle.
Oh, A.
A. A is the smallest angle of the biggest triangle, so I put A. You see? Now what about the middle triangle? Which is the letter for the smallest angle of the middle triangle? A. Look. It's C, D, or A. See? But A is the smallest angle. And in the smallest triangle here, which one is the smallest angle? C, B, or D?
C.
C. Here you go. And then the last thing is just the last angle that's left. Well, the last angle is like the middle angle, right? Not the smallest angle, not the right angle, but the one in between. So let's take a look. For BCA, which is the last angle that's left? It's just the last letter, right? So I've got BCA. The only one that's left is B. So there you go. You put B. And DAC, the only letter left is C, right? So you put C. Once you've put the other two, you just put the last letter. And DCB, the last letter is B. So there you go. And once you've done that, you've got your similarity statement. You say triangle CAB similar to triangle DAC, which is similar to triangle DCB. Does that make sense to you guys? You can't just put the letters in any order you want. They have to be in order of the angles. Does that make sense to you guys? Okay. All right. So, what was that?
You put the similarity sign.
Yeah, the similarity statement is this whole thing. Does that make sense? Yeah?
What about, like, get water in my head?
Sure, go ahead. All right, CAB, DAC, DCB, that's a similarity statement. Does that make sense? Okay. All right, now you have this example question. So go ahead and do the example question for this one. So it's the example on the very bottom. Number 1. So write a similarity statement comparing the three triangles. Let's go ahead and do that now. Write a similarity statement comparing the three triangles. Doing this question. Write a similarity statement comparing the three triangles. So I wrote the similarity statement here. You should write a similarity statement about those three triangles. First, you have to identify the three triangles and then put the letters in the proper order.
This triangle. There's three. One, the big one, JKL. Two, JKL.
Yes, good job.
Well, I think I did it right. Is it right? It's this way. L and K. L. Oh, L. I know what you mean now. That should be J, K, M. I think.
You should be trying not to say that.
Oh, the angle. Okay.
This right?
J is the right angle, that's good. But L is not the smallest angle.
Now, let me be very clear, guys. You don't have to do it the right angle first, then the smallest angle, and then the middle angle. You don't have to do it that way. You could do the smallest angle first, then the right angle, and then the middle angle. Or the middle angle first, then the smallest angle, then the right angle. It doesn't matter what order, but you have to have the same order for all the triangles. That's how you do this. Does that make sense? Okay, so let's take a look. I'm just going to write it all at once. So for the biggest triangle, I go right angle, smallest, middle. So it's going to be the right angle is J, then smallest is K, and then the middle angle is L. So that's similar to this middle triangle. The right angle is M, the smallest angle is K, and the middle angle is J. And that's similar to the smallest triangle, which is the right angle is M, the smallest angle is J, and the middle angle is L. Does that make sense to you guys? Yes, sir.
So let's just say like if we kind of got mixed up a little bit, like for the first part, LKJ, it'll still be wrong.
The only way it would be right is if this was LKJ and this was JKM and this was LJM. If they were all flipped, then that'd be fine. But if one of them was flipped, then no.
Okay.
Because it has to be in the same order. J has to be in the same place as M. You see? And K has to be in the same place as K and J. In this one. Alright, so now let's go ahead and do the Kahoot. We're going to do one question. And then we're going to do one question and then we're going to do the rest of the lesson. Okay, so get out your device because I think it's better this way. Then it breaks up the lesson, not just like hearing you actually doing example problems. It's like taking a role, taking part in it.
That's around song 4. Well, for the learning, because if you don't know what learning, just so this one.
We're going to just do lesson 8.2.
There's nothing in the quiz, right?
No, there will be a quiz, but you can make it up.
Can I make it
It's gonna be funny.
like Friday?
Sure, make sure you log in. Who are we waiting for?
Who do you have? That's gonna be so funny.
You can do it that day if you watch the video.
Yeah, because I come back at 2 o'clock to start with.
Yeah, so you can do it that day, but you'll have to watch the video first. You'll have to watch the lecture first, understand the quiz. All right, is everybody in? Yes. All right. Who just logged out?
Oh, that might have been me. My phone just turned off.
Okay. All right. So your first question is exactly what you just wore on, and just stay logged in because we're going to keep doing this throughout the lesson. So the best way to do it is to write it down on a piece of paper first. How do you guys before you do that? Just I don't know how you guys got answers. So notice the first triangle is the same on all of them. It's PQR. So you got to match it with PQR. So PQR is the right angle, then the smallest, then the middle angle. So you're going to have to match that for the rest of the triangles. So what should the middle triangle be? Well, the middle triangle should be SQP, because Q is the smallest. S is the right angle, then Q, then P. So you can just look, oh, that's the only one with SQP, right? And then this one should be SPR, and there you go. Just like that. All right, cool. Priscilla's in the lead. Nicely done, Priscilla. All right, so next, go flip to your next page. So we're done with the Kahoot for now. So flip to the next page in your packet. This is actually probably the easiest thing that you're going to learn in all of geometry. Okay. So look, it's called the geometric mean. So, yeah, it's easy, but it's mean. No. Okay, So in that blank, guys, in that blank, put the geometric mean of two positive numbers is the positive square root of their product. So what does that mean? If I have two numbers A and B, guys, pay attention. This is the easiest thing that you just want to be able to get right. The geometric mean of A and B is, if the geometric mean is X, the geometric mean is the square root of A times B. Okay? So let's say I have 2 and 32. 2 and 32, let's say. Right? Well, then the geometric mean will be the square root of 2 times 32. What's 2 times 32? 64. So square root of 64 is 8. So there you go. That's how you get the geometric mean. You multiply the numbers and then you take the square root. Just like that. That's easy. Does that make sense? The geometric mean, you multiply and then take the square root. Does that make sense? You guys think you got that? We're going to do an example problem first. Okay, so now. Shh. So look, 4 and 9, guys. 4 and 9. Find the geometric mean of 4 and 9. Well, they multiply the two. 4 times 9 is 36. You take the square root. You get 6. Just like that. 6 and 15, they get 90. Take the square root. You get square root of 90. Does that make sense? Yeah?
Yeah.
Okay,
So
so
square root of 90 is 3.
3 radical 10 because you pull out the 9 and you get the square root of 9 is 3, so 3 times radical 10.
27.
So
You
90.
can just, guys, you can just leave it as the square root.
You can't solve it.
And I'm probably going to give you guys extra credit stuff with simplifying square roots
So like if you
over the break.
over the break,
Yeah, I'll be
Yeah, we're fine. Don't worry about it.
What?
We're fine, don't worry about it.
It's extra credit. What you sleep, I get extra
How many
credit.
Oh, wait, extra credit.
Yeah.
Oh, yeah, but I thought it was Just kidding, Mr. Williams.
I mentioned I'm fine. What are you talking about?
Well, then it is what it is, right? You just try it if you can. If you can do it, then do it. Okay, guys, do these three. Do these three. Go ahead.
So,
And just leave them in square root form.
No.
I
Okay,
just
so then
thought
we
about
times-
it just now.
So we times them by
I just thought of it.
will it be
And
square
then-
with this?
and then we
With square
square.
roots, probably. Is what I'm thinking.
I think I
Yeah, but then you start to multiply the negative square root.
So then yeah, that's it. 34. You do it so hard.
This
8 times 9.
Square root.
is
72.
with this section.
27.
So this one.
Good. Yep.
Wait, after you get the answer.
You square
Okay,
it.
where
But
do you
did you
see-
want us to square or if you don't know?
Square root.
It's
Okay, shh. Let's watch the first one. Guys, quiet.
Why does it X
Shh. Olivia, just pay attention. So look, 2 and 8 is the square root of 2 times 8. What's 2 times 8?
16.
What's the square root of 16?
4.
Oh, I
4.
thought you were kidding.
Okay. Now,
Those are the 3 questions on the bottom.
shh.
Oh, I thought we were doing 2
We just did. Square root of 2 times 8 is square root of 16, which is 4. Square root of 10 times 30
300.
is 300, and that's good enough for now. God bless you.
So then
Square-
leave that one 300.
Yeah. Square root of 8 times 9
72.
is 72. We don't know that, so it's just square root of 72. That's good enough for now.
So then if it's like simple, you should know it. Then you have to write it. But if not,
Yeah.
it's okay.
For now. God bless you. But then I'm going to give you guys the extra credit for doing square roots, where you're going to have to learn how to simplify square roots because you guys already know how to do it. What? No, it'll be something. I'm not sure.
What kind of?
I'm not sure.
You know, I'm not going to complain about that.
All right, you guys ready?
Yes, I'd be happy.
How?
Find the geometric mean of the two numbers. Go ahead. 2 and 50.
That's wrong. Yeah.
Right.
Don't
I just
square
told
it. Let's use the right terminology. You think the
Square
square
root.
root.
Marcus, what's the square root of 349?
726.
Okay, guys, for this one, what was this?
Fourth place.
The square root of 2.
Square root of 2 and 50 is square root of 2 times 50, which is square root of 100, which is 10. Okay, so the geometric mean is just 10 for that one. Good. Sam's in first. Nice. Okay.
First place.
Shh.
I'm in second.
All right, now turn to your last page. Now, guys, this is the most challenging part of this lesson, so you really got to pay attention. Now, look. We have 3 triangles, right? And what they've done here is they've taken the middle triangle and put it here, the smallest triangle and put it here. They rotated them, you see? So this one, they like flipped it around, and so it's just like that now. That's the middle triangle. And that is this smallest triangle here. You see it? Okay, but what do I know about similar triangles? Well, the ratio of B to A is the same as the ratio of Y to H, which is the same as the ratio of X to H, you see? And that's what it's showing here.
Like a line drawn to it,
See?
or like the distance.
B over A is equal to Y over H, which is equal to X over H over X. Does that make sense? The ratio of these sides to each other is the same for all triangles because they're similar. You
Is it
see?
any-
What was that?
Could it be any, like, if it's like B over Y? Or
And now look, this next one says C, this is C over A, is equal to B over H, which is equal to A over X. You see? That's what this next one says. These ratio, you guys following this?
yes.
the ratio of this side to that side is the same for all triangles. That's what this one says. You see? And what this one says here is C over B. So this side over this side is equal to B over Y, which is equal to A over H. You see? Because they're all similar.
Wait,
Now-
can you do the second one again? C over A. Wait, what was it?
C over A
Oh.
is equal to B over H, which is equal to A over X. Okay. So the ratios are all the same, but now let's do a little bit of algebra and check something out. All right? Shh. Guys, let's not lose focus. Let's not lose focus. Shh. Every time something like that, guys, every time something like that happens in this class, our brains go from being focused to not being focused. So let's not do that. Let's stay focused. Okay? So let's try. We have to try. All right, now look. Let's take a look at this. Let's use these two here. I get y over h equals h over x. All right? Now, I'm going to multiply both sides by h. This goes away, and I get y equals h squared over x. Then I'm going to multiply both sides by x, and I get h squared equals xy. You see that? So h squared, this squared, equals x times y. You see that? Does that make sense to you guys? So, what did I do? Look, what did I do? What did I just do? I just cross multiplied, right? I just cross multiplied. I got xy equals h squared, right? So, what did I find? These ratios, we agreed that those were correct, right? Well, what did I find? I found that this side squared equals this times this. You see that? Does that make sense to you guys? So I just figured out that this squared equals this times that. Does that make sense?
DC squared equals.
No, h squared equals x times y. You see? Does that make sense?
What?
Look,
So DC.
dc squared equals bd times ad. But this it's marked as h, x, and y, so you don't need to.
They don't look the same way.
No, the square. H squared.
Oh,
This
half the-
squared equals this times this.
Okay.
Okay? So we just found that because of these ratios. Does that make sense to you guys? We found that this is true. This is a true statement because of those ratios. Now let's use these two. Look. C over A and A over X. So we get C over A equals A over X. Cross multiply and we get A squared equals CX. Does that make sense? Or let's say X times C. So look, now we look at this triangle. Sorry. Now we look at this triangle and we see a squared, so this side squared equals x times c. See that? So a squared equals x times c. So that's our second thing that we just found. And because I'm using these, look, remember I went through, I took the time and I said, oh, this side over this equals this over that, right? And I got these ratios here. I said all these ratios are the same, right?
Yeah.
Well, now I'm just using them and I'm just rearranging them to figure out these things. Does that make sense?
Why did they only do like those in particular, like the first and the last one? How come not like C over
It's
B over H?
because what we're doing is we're proving something. I'm showing you why these things are true. Rather than just saying, oh, these things are true and you just use them this way, I'm showing you how we get them. Does that make sense? Right. So the point is that by showing you how I'm getting it, it's not just a trick. You see? It's something that we can understand because the math is emergent. All right, so let's take a look. Let's use these now. So I get C over B equals B over Y. I cross multiply, and I get B squared equals Y times C. And that's the third one. You see that? Does that make sense, guys? So now I say this side squared equals y times c. You guys see that? Okay. Now, take a look right below here. And where an example, read those three equations right under the word example. Do those look familiar? Yes. Where did we get those from? Yeah, what we just showed. You see what we've been doing? We've been deriving those equations. All right. So now let's take a look. Let's take a look at how we can use this. All right, because those were the equations. We figured out how we can get those equations. Now let's take a look at how we can use it. Let's take a look at how we can use it. So, first off, h squared equals x times y. H squared equals x times y. So this squared equals this times this. Okay? So this squared equals this times this.
Which way?
H, you see the altitude? This is the altitude. You see how the altitude breaks the hypotenuse into two line segments, x and y? You guys see that? Can you see that? Well, if I square h, then h squared is equal to the product of those two line segments, the length of those two line segments. That's what we just found. Does that make sense to you guys? So for instance, let's say that this was 4 and this was, let's say this was 16. This one's 4 and that's 16, right? And I ask you to solve for h. Are you guys watching? Let me pick your hand up, please. If this is h, I'm trying to solve for h, right? So, well, this tells me that h squared equals x times y. So h squared equals x is 4 times y is 16. You see? So h squared equals, what's 4 times 16? What's 4 times 16?
64.
64.
I guessed hard enough before. You guessed hard enough.
So h squared equals 64. What do I do to solve for h? Square root. Exactly. So h equals the square of 64, which is just 8. Does that make sense? So that's how I would use that. You see?
What was the whole purpose of the XY thing?
The whole purpose is, if I give you this and tell you to solve for this, that's how you do it. Does that make sense? This just equals the square root of the product of those two numbers. Does that sound familiar? What's the square root of the product of two numbers? Flip back to the previous page. Read what it says right at the very top of your paper. There you go. So h equals the square root of xy, so h is the geometric mean of xy. Does that make sense? Okay, so that's what we just found. Now, next.
When we see this as problems, will they have the XY thing or will they actually have numbers?
They'll have numbers. And you'll have to be able to figure it out. Because look, so now the next is a squared equals xc. So take a look at this. A, I'll put in blue, and x I'll put in blue. You see how they're both on the same side of that altitude? You see that? So a squared equals x times c. C is this whole length. You see that? So a squared, or a is the square root of x times c. Well, x is 4, so a is the square root of x times c, right? Because a squared is xc, so a is the square root of x times c. Does that make sense to you guys? So what's x in this picture that we drew? 4. X is 4. And what's c? 20.
What?
C is this whole distance. C is 20. You guys following me? C is 20. So a is the square root of 4 times 20, which is just the square root of 80. Okay? Yes, sir.
There's something I didn't get on the test. Like, for example, what if you had 4 for A and 21 for C? Like, how would you find B if you had A and C?
I'm not going to go into that right now because that's, yeah, it's, That's just going to confuse people. It's just going to confuse people for this lesson. Okay. I understand. So,
That's where I'm looking.
so look, are we following this? Look, if I want to get this, it's the square root of this segment, the one that's adjacent to it, the one that's touching it. You see that? Okay. So A is the square root of this times this whole length. Now, what about this one? What if I want to solve for B? Well, look. You see how Y and B are both on the same side of the altitude?
Are they congruent?
They're not congruent. No. I'm just color coding it so you guys can learn this more easily. B equals the square root of not XC, because X is on the same side as A, so A is the square root of XC. B is the square root of YC. Does that make sense to you guys? You see how you can remember it? YC. B is the square root of YC. So what's Y in this one? What's Y? 16. So square root of 16 times C is 20. What's 16 times 20? What's 16 times 2?
32.
2. So add 0, it's
320.
320. Does that make sense? You guys understand this? Okay, so now let's do some example problems. Okay. Oh, that's annoying. Why would they do that? Okay. Shh. Let's take a look at this question here. So find X, Y, and Z for this one. How do we do it? Well, this is the altitude, right? So the altitude is the square root of this times this. You guys, so try and level with me here for a second. Everyone just give me your attention. If you're asleep, okay, fine. Wake up.
Do we have a different one?
Shh. How are you solving these questions? No, I didn't. You're not going to do this one.
Oh,
You're
okay.
doing this one. How are you, everyone eyes up. How do you solve these questions? Do you solve them with just knowing a formula? No. You have to be able to see visually what I'm talking about. The altitude is the geometric mean of the length of the two line segments that are formed when it's being split, when the hypotenuse is being split by the altitude. So you see, the altitude splits the hypotenuse into two line segments. You see that? Okay? The length of the altitude is the geometric mean of those two line segments. Simple as that. You have to be able to understand that concept, be able to remember it, and be able to recognize it visually. The altitude splits the hypotenuse into two line segments. The length of the altitude is the geometric mean of those two line segments, which means it's the square root of their product. So if I'm asking you to find x, well, x just equals the square root of 2 times 10, which is the square root of 20. Does that make sense? That's all you got to do. That's very simple if you can understand that concept and recognize it visually. If you can do that, then this is just that simple. Square root of the product. Easy. Okay? So you got to be able to do that. You got to be able to recognize it. Now, y, now this is a little different, right? Y, I'm not trying to find x anymore. I'm not trying to find the length of the altitude. I'm trying to find the length of this side of the triangle. Well, this altitude splits this hypotenuse into two line segments, and one of those line segments is on the same side as this side, right? That's why I'm color coding it in blue. Well, this side of the triangle equals the geometric mean of this line segment and the length of the hypotenuse. So this, the length of this side of the triangle is the geometric mean of this line segment and the length of the hypotenuse. What's the length of the hypotenuse? 12. So that line segment, y, or that side of the triangle, equals the square root of 10 times this part times the whole length, which is 12, which equals the square root of 120. Okay? That's the concept you have to know. This side of the triangle is the geometric mean of this line segment and the whole length of the hypotenuse. You have to be able to know that. Yes, sir.
So for z would be 2 times 12.
Exactly. Now z, on the other hand, z is on this side of the triangle, which joins up with that line segment, which is on the same side of the altitude. You see that? So z is the geometric mean of this line segment and the whole length of the hypotenuse.
2 and
Okay?
12.
2 and 12, exactly. So z equals the square root of 2 times 12,
So then
or
24.
square root of 24.
And
just
then
like
this-
that.
So then z equals the square root of 24.
Yes,
That's it.
that's it.
What if we're asked to find what x is?
You already found what x
Or
is.
not x, like if x is already filled and we're trying to find what 10 is.
Wait,
That's a harder problem.
Wait, but what's x?
That's a harder problem, and I'm not going to go into that right now.
Well,
What
that's in the example.
That's exactly in the example.
What was x?
But I want you guys to think of that for yourself, and I'll go over it in the homework. Because if I try and go over, it's right there, Marcus. It's right
Oh,
Wait, we just reverse it?
there. What was that?
Reverse it?
No, it's hard. I'm not going to go into it right now because it's too much. So, do you guys understand this?
Yes.
The concept is important. The math, the arithmetic is simple. You have to know the concept. You have to be able to recognize it visually. All right. Now, Kahoot time. Okay. Shh. Look. Look. It's the same type of question. It's the same thing. Find y. Look, it's an altitude. It splits the hypotenuse into 2 line segments. Come on. The altitude is the splits the hypotenuse into 2 line segments. The length of the altitude is the geometric mean of those 2 line segments. So what's the geometric mean? It's the square root of the product. So the length of y is the square root of 6 times 4, which is the square root of 24. There you go.
How'd you get it right?
First place.
How? Yes, you did.
Solve for x.
Yeah.
Now look. Shh. Now you're solving for this side, right? So it's not just 6 times 4 anymore. You got to think, what is it? Times 12.
Times 10.
Remember, guys? And this is why you should start bringing colored pencils into those tests. Some of you did.
So it'd be 6 times 10.
Yes. This side length is equal to the geometric mean of this line segment and the whole length of the hypotenuse. What's the whole length of the hypotenuse? 10. So this is the square root of 6 times 10, which is radical 60. Good.
First,
Solve for z.
It's
6 times.
Is it going to be 6 times this time?
Wait, what are we solving for? Z? Oh no.
Solving
4.
for z.
4.
10, right?
What was the answer? Y.
Y was radical
Look, you see
24
this? You see this?
Why was it radical?
because it's the square root of the product. The product is 24.
Yeah, but can't you just, from the square root, it's 12, right?
You're
No, that's divided by 2.
Okay.
So look, this one, this side length is equal to the geometric mean of this line segment and the hypotenuse. What's the length of the hypotenuse? 10. So the geometric mean of 410 is the square root of 4 times 10, which is the square root of 40. Nice, good job. All right, that's it for our lesson. Go ahead now, you guys have 5 minutes to do your quiz. Do your quiz, do your quiz, do your quiz.
What's this last question here on the paper thing?
Are you okay for some?
Which one?
The last question?
Yeah,
I don't know.
I'm not first.
It's just too confusing.
Okay, G, let's do the quiz. Let's do the quiz. Remember, it's open notes, so you just use your notes. It's all the same as what you've already done.